Okay, so I told you in the last class some introduction of electrolysis and some equations. Like I gave you some ions, positive and negative ions. Then we did like what the ion. Let's suppose I have a positive ion, so it would be going towards cathode because cathode is having a negative charge. And I was telling you the introduction of electrode. I was telling you that electrode is nothing but it's a plate which is a good conductor of electricity. When this plate is attached to the positive terminal of the battery, that would be called anode. And when this plate is attached to the negative terminal of the battery, then that would be called cathode. So this is the difference between cathode and anode. It's totally up to you. It's totally up to you. You can make cathode, you can make anode. It's up to you. Okay, because it's depending on that, like from where you are going to attach your material. Let's suppose you have graphite, and you all know that graphite is a good conductor of electricity. Okay, so graphite can be used as an electrode due to this reason that this is a good conductor of electricity. So when you are going to attach graphite to the negative terminal of the battery, so I can say that this is cathode. And when you are going to attach graphite with the positive terminal of the battery, then I would say that this is anode. Okay, I told you what is electrolyte. Okay, electrolyte is a solution which is a good conductor of electricity. And then I told you this is the apparatus, like how can we assemble different things. Like we have a beaker, then we have different electrodes, then we have wire, then we have battery. Okay, and the very important thing that you need to know is the direction of electron. Direction of electron is from negative to positive, just like that. From negative to positive. Okay, from negative to positive, just like that. Okay, from negative to positive, remember. So today we are going to start. And also one thing that I need to tell you, I just told you introduction of an electrode. Now I'm supposed to tell you there are two types of electrode, cathode and anode. There are two types of electrode, as you can see, cathode and anode. Cathode is negative, anode is positive. Cathode is negative and anode is positive. Simple. Okay. And then uh, on the basis of reactivity, we can also classify electrodes, just like we can say that we have two types of electrode. The first one is reactive electrode, okay, and the second one is inert. The first one is reactive electrode and the second one is inert. First one is reactive and the second one is inert. Okay, inert means unreactive. Inert means unreactive. Okay, an example of inert electrode is graphite. Graphite. Okay, reactive, in our syllabus we would be discussing copper. We would be discussing copper. Okay, basically reactive electrode takes part in a chemical reaction and inert electrode does not take part in a chemical reaction. This is the difference between reactive and inert electrode. Okay, you are supposed to write it down. Reactive electrode takes part in a chemical reaction. Okay, in a chemical reaction inert electrode does not take part in a chemical reaction. Okay, this is the difference. Okay, so you need to memorize this. Okay, so we are going to start electrolysis of sodium chloride. We are going to start electrolysis of sodium chloride. Uh, we have different cases, like sometimes we have molten sodium chloride, sometimes we have aqueous, dilute aqueous sodium chloride, and sometimes we have concentrated aqueous sodium chloride. Okay, we have three cases we would be discussing. Number one, electrolysis of molten compounds. Electrolysis of molten compounds. Number two, electrolysis of dilute aqueous. Electrolysis of dilute aqueous, and electrolysis of concentrated aqueous. Okay, so we would be discussing electrolysis of these three cases: molten, then dilute aqueous, and then concentrated aqueous. Molten means there is no water. Molten means when the water is absent. Molten means when the water is absent, basically. Okay, when the water is absent. Basically, at a higher temperature, we have melted a compound. Basically, it's nothing but at a higher temperature, we have melted a compound. That's it. But why? You know that when the compounds are in a solid state, so they are bad conductor of electricity. They are bad conductor of electricity. And we were discussing in the last class that if the compound is a bad conductor of electricity, ultimately you can say that the compound would not be breaking down. So as a result, you cannot say that like we have electrolyzed the compound and the compound is broken down to give you the respective, you can say, elements. Sometime, let's suppose right now I'm taking sodium chloride. So when I would be breaking down this sodium chloride, so I would be getting sodium and chlorine. Obviously, I would be getting sodium and chlorine. Okay, so this is molten sodium chloride. This is molten sodium chloride. Molten means there is no water, and in a molten state, the compound is a good conductor of electricity. Okay, so first one is that when you would be providing electricity to the sodium chloride, after providing electricity, this sodium chloride would be breaking down to give you Na positive ion and Cl negative ion. Okay, always remember, in any compound, the first part is positive and the second part is negative. First part is positive and the second part is negative. Always remember, in any of the compound. Okay, so this is the reason when I had sodium chloride and I have provided electricity to this sodium chloride. So the sodium chloride has broken down into this Na positive ion and the Cl negative ion. Okay, then what would happen? You will see that in this beaker, a lot of Na positive ions and a lot of Cl negative ions are there. Okay, once you have provided electricity and the compound is broken down, so you would see a lot of cations and you would see a lot of anions. You will see a lot of cations and you will see a lot of anions over there. Okay, so then what would happen? Then in the last class we were practicing, that if we have a cation, then what we are supposed to do? If we have a cation, then what we supposed to do? Obviously, this positive ion will go towards cathode because opposite charges attract each other. Okay, this positive ion will go towards cathode. And you know that cathode is having a negative charge because cathode is attached to the negative terminal of the battery. So it has a lot of negative charges. It's mean that it has a lot of electrons. It has a lot of electrons. So Na plus needs one electron. I told you in the last class, if any ion has plus one charge, it means that it needs one electron. If any element is having plus two charge, it means that it needs two electrons. And if element is having plus three charge, it means that it needs three electrons. Right now, Na is having plus one charge. Right now, Na is having plus one charge. What does it mean? What does it mean? When Na is having plus one charge, so it would be gaining one electron. Okay, it would be gaining one electron, and it would become neutral. It would become neutral. Okay, it would become neutral basically. So this is your equation at cathode. This is your equation at cathode. So what's happening at cathode? Na plus is going towards cathode, and then it's gaining one electron, and then it would be coming neutral. When the sodium becomes neutral, remember, when the sodium becomes neutral, so this is the solid state. This is the solid state of the particular metal. If any metal, if any metal is having a zero charge, if any metal is having a zero charge, it means that it's in the solid state. It's in the solid state. Okay, when any metal is having a positive charge, having a zero charge, it's mean that this is in solid state. Okay, it's mean that this is in solid state. So you will see that at cathode the sodium would be deposited. You would see that at cathode the sodium would be deposited just like that. Sodium would be deposited just like that. You will see that the grayish white solid is formed at cathode. Okay, this is the sodium metal. And then what would happen at anode? Obviously, the Cl minus is going towards anode, and you know that anode is a plate which is connected to the positive terminal of the battery. And ultimately, when the Cl minus ion will go towards anode, when the Cl minus ion will go towards anode, then it would lose one electron. It would lose one electron. Why? Because I told you that when anything is having a negative charge, it's mean that it has extra electrons. When something is having minus one charge, it's mean that it has one extra electron. When something is having minus two charge, it's mean that it has two extra electrons. The same way, when something is having minus three charge, it's mean that we are having extra three electrons. Okay, we are having extra three electrons, remember. Okay, so right now the Cl minus is having minus one charge. It's mean that it has one extra electron. Then it would be losing its extra electron to the anode, and then it would becoming neutral, and then it would becoming neutral. Okay, okay, it would becoming neutral. Now if you can notice that positive ions gain electron, negative ions lose electron. When electron is gained by the species, so you would be writing electron on your left hand side like that. And if someone is losing electron, so you would be writing electron on your right hand side. Okay, so you can also identify whether the substance is going to gain electron, whether the substance is going to lose electron. Simple. Okay, then now I'm going to tell you the thing that I didn't tell you in the last class. Okay, so today you must know that this is chlorine, and chlorine is always stable in the diatomic form. Remember, chlorine is a diatomic gas. This is in group 7. All the group 7 elements are diatomic. F2, Cl2, Br2, I2, At2. They all are diatomic, like H2, N2, O2, F. So you must know that which is diatomic and which is not. Obviously, chlorine is diatomic. So then you would be writing 2 over here by yourself. Examiner would not tell you. Examiner would not give you a hint. Even he is not going to give you any type of hint that you can understand that you are supposed to write to in the subscript of chlorine. No, never. He's not going to give you, he's not going to tell you. Okay. So you must know that chlorine is in group 7 and it's like halogens, and all halogens are in the diatomic form. So ultimately you would be writing 2 over here. Ultimately you would be writing 2 over here. Okay. So then what am I supposed to do? Then what am I supposed to do? I am going to write the overall equation. I am going to write the overall equation. I am going to write the overall equation. So you can see this. You can see this. Na plus E minus Na0. Cl minus lost electron Cl. As you know that this is unstable in monoatomic form, you are supposed to write 2 in the subscript of chlorine. You are supposed to write in the subscript of chlorine, okay? You are supposed to write. I would be writing 2 over here, 2 over here, 2 over here. Fatma, you are late. Fatma, you are late. Okay? So I'm supposed to add these 2 equations. So remember, whenever you are going to add 2 equations, remember, whenever you are going to add the 2 equations, so you are supposed to make the electrons same. I mean to say that in the second equation, you have 2 electrons. In the first equation, you have 1 electron. So what am I supposed to do? I would be multiplying equation 1 by 2. What's the benefit of multiplying the equation by 2? Electrons are same, you can cancel electrons. That's it. So what would be the things that I need to write after this overall? After adding them together, I would be writing when 2 Na positive ions would be meeting with the 2 Cl minus ions, they would be reacting together. They would be forming sodium chloride. And then I would be writing 2Na and then Cl2. Most of the students ask, sir, why did you write like this? Why aren't you going to happen in the product side just like that? Why? Beta, these have charges. There is no charge. They are neutral. Why I'm going to attach this? I'm not supposed to attach this. Charges attract each other, not the neutral ones. What the equation tells? This equation tells you that when you are going to do electrolysis of sodium chloride, then you will have sodium metal and chlorine gas. So this is the outcome of this electrolysis. You would be getting sodium metal and you would be getting chlorine gas. Then what's the observation? Then what's the observation? Then you would see in that beaker, in that container, you can say that at cathode, the silvery white solid is deposited. That is the sodium metal. The color of the sodium metal is silver white. Silvery white solid is deposited at cathode. Silvery white solid is deposited at cathode. Silvery white solid. And at anode, chlorine gas is produced. What's the color of chlorine gas? You will say, sir, pale green color. Yes. You will see the pale green color of the gas that would be observed at anode. Greenish yellow gas, pale green gas, that's the same thing, okay? So pale green gas is observed at cathode. Sorry, yes, at anode, okay? So these are the observations that you need to know, okay? That's all for the electrolysis of sodium chloride in the molten state. In the molten state. Now, let me summarize it. Whenever the examiner would be giving you any type of electrolysis, then you are supposed to write this equation first, then this equation, and then this equation. That's it. Okay. Yes, I'm going to give you another compound, and I'm expecting to write all of the things that I did for the sodium chloride molten. Okay. This is calcium chloride molten. I need all the data as sodium chloride molten. Fast. I'm going to give you 2 minutes. So now I'm going to tell you calcium chloride. Okay. So for the calcium chloride, I was expecting from your side that you are supposed to write, first of all, I'm going to write in red color. Okay. First of all, you are supposed to write this equation. Then this calcium 2 plus will gain 2 electrons. And then you are going to write this equation just like that. That's it. That's it. Very easy. Very easy. It's so much easy. It's very easy. That's it. That's all for the electrolysis of calcium chloride. First of all, the first equation is going to represent that how the compound is going to broken down by means of electricity. And then we are going to show that calcium is going towards cathode because cathode is having a negative charge and this is positive ion. So it would be gaining 2 electrons and would become neutral. And this is Cl negative ion. It's going to lose electron. Ultimately, chlorine is a diatomic molecule. I'm supposed to write 2 in the subscript of chlorine. Then for the balance equation, I'm supposed to write 2 and 2 over here. So that's all for the electrolysis for what? The calcium chloride. Okay. Are you all getting my point? Any question? Yes. Is that clear? Adan, Anaya, Amaya, Aryan, Fatma, Amna, Huria, Mahin, Mohimin, Reni, Humar. Yes. Is that correct? Are you all getting my point?
Yes.
Should I go ahead? Okay.
Yes, sir.
Yes, sir.
Okay. Now you have this electrolysis. Fast. I'm going to give you only 1 minute. Fast. Okay, so you did just like that. First of all, you have provided electricity to this compound. So your compound has broken down into this ion. Okay. Then the magnesium 2 plus ion will go towards cathode, will gain 2 electron and would form Mg. And this O2 minus will go towards anode. It produce 2 electrons. Okay, then O2 minus is losing 2 electrons to become what? O. As you all know that O is also a diatomic gas, then I would be writing 2 over here. To balance this equation, I would be writing 2 over here. So each oxygen was losing 2 electrons. So ultimately, now we have 2 oxygens. So 2 oxygens would be losing 4 electrons. Two oxygens would be losing 4 electrons. I'm supposed to write 4 over here. And then I would be adding them together. So I told you that to balance equation, to add equations, electrons must be the same. Must be the same. In the first equation, I have 2 electrons. In the second shell, I have 4 electrons. I need to multiply this equation by 2. Okay, they would be canceling each other. Let me just multiply this by 2. This would be 2, this would be 2, and this would be 4. Now they would be canceling each other. As a result, I would be writing just like that. And that's it. Okay, hopefully you understood that whenever the examiner would be giving you the compound, so then how you would be breaking down the compound, and then after breaking down the compound, you would be getting 2 types of ions. The first one was the cation, and the second one is the anion. So then then you would decide, then you would think that if we have cation, that is a positive ion, so it would travel towards cathode. Ultimately, opposite charges attract each other. And if we have negative, like negative ion, so the negative ion will go towards the positive electrode. Opposite charges attract each other. That is very important to know. So that's all for the electrolysis for sodium chloride, and then calcium chloride, and then magnesium oxide. Same goes with calcium oxide. A lot of electrolysis that we have to do. But that's all for aqueous. So sorry, that's all for the molten state. I told you all the molten cases. Molten cases are so much easy. Molten cases are so much easy because there is no water. Water will not interrupt you. Water will not interrupt you. There is no water. It's molten. It's melted at a higher temperature. That's it. Because in the water, you would see that H positive ions are also interrupting you, and OH negative ions would be also interrupting you from the water molecule. Okay, so remember. Okay, then we have electrolysis of aqueous dilute aqueous sodium chloride. What do you mean by dilute? What do you mean by dilute? Remember, dilute means more water and less sodium chloride. Dilute means what? More water and less sodium chloride. Let's suppose you have dissolved salt in water, but you have taken more amount of water. But you have taken more amount of water. So when you have taken more amount of water, it means that this is dilute solution. When you have taken more amount of water, it's mean that this is dilute solution. Okay, so this is called dilute. This is called what? Dilute. And then we have concentrated. Then we have concentrated. Concentrated means that when the water is less and the and we have more sodium chloride. When you have more sodium chloride and less water, it's mean that this is concentrated. It's mean that this is concentrated, right? And aqueous means the substance is dissolved in water. Aqueous means the substance is dissolved in water. If the water is higher, like if the water is in greater quantity, it's mean that this is dilute. And if the water is in the lower quantity, means the solvent is in the lower quantity, you would say that this is concentrated. Okay, but aqueous, you would use the term. You would use the term aqueous when there is no molten case. So you would be using the term. You would be using the term aqueous. Okay. Okay. So that's it for the molten case.